Graphs of functions. Graphs are one of the most powerful ways of visualizing a function's rule because you can quickly see the inputs and the outputs. Okay? I love, oops, sorry, I'm on the wrong thing. I do love graphs, okay, because it gives you that visual to see your inputs and outputs. You can also easily see features such as a maximum or a minimum, meaning a high point or a low point of your output values. So let's take a look at this first function. It says, given the function y equals f of x defined by this graph, answer the following questions. So when I look at this particular graph, it's nonlinear, okay? It's not a line. So let's write that word down, nonlinear. And particularly, later on in the year, we'll learn more about these nonlinear functions. This is a quadratic function. Okay, it's a quadratic. It says find the value of each of the following. So when I take a look at this, I've got f of 4. So f of 4 tells me that my x value is 4, so go ahead and read from your graph, 1, 2, 3, 4, okay? And what's the value of it? It's 1. What about f of negative 1? Go and meet the graph, okay? F of negative 1 is a positive 6. It says for what values, okay, plural there, of x does f of x equal negative 2? So where does f of x equal negative 2? In other words, where is the y value negative 2? So if I go to my y at negative 2, if I draw that line in there, because that's where y equals negative 2, I've got 2 points. So my first point, my first x value is 1, and my second one is 3. So I got an x equal to 1 and also an x equal to 3. Part C, state the minimum and the maximum values of the function. Okay, the minimum values, the lowest value of this function, okay, does occur right there. So that minimum value, we'll just say min, is where y is equal to negative 3. And then what is the maximum value? Okay, the highest point to this graph, okay, is right up here, and that ends up being where y is equal to 6. Now notice, at the top of this graph, where I just filled in blue, there are no arrows there. It's an end point. So this parabola, or this quadratic function, doesn't extend to positive infinity. It ends, okay, its highest point is that 6. So it says, if we continue on, it says, so if we read a graph to produce outputs, y values, if we are given inputs, x values, then we should be able to reverse that process, okay, and produce a graph of the function from its algebraically expressed rule. So we're given this linear function, g of x is equal to 2x plus 3. Okay, 2x plus 3 is going to produce a line, so it's a linear function. It says fill out the table below for the given inputs given. So we have our function, 2x plus 3, and then we have our input column, and then we end up with, hang on just a second. Okay, I'll continue on. Sorry, I had to pause that for a second. So we've got to come up with the x comma y, the point. So the given input with the output that we found to produce that point. So because my function is 2x plus 3, I'd say 2 times negative 3 plus 3. So that's negative 6 plus 3, which would give me an output of negative 3. So then my point, my x comma y, is going to be my input comma the output that I just found. Okay? So I could do that a second time. 2 times negative 2 plus 3. So I've got negative 4 plus 1, or excuse me, plus 3 is negative 1. That's the output, so what's the point? -2, comma -1. All right, it's a little cumbersome, so let's go to our graph, our calculator. And let's type this in and we'll look at the table. So on the calculator, you're going to type in that function rule on a graphing page, so 2x plus 3, hit enter. So there's my line. Well, I need the points that go with that line. So if you hit Control T, T for table, that's exactly what it's going to bring up. And if you click your up or down arrows, you see that it scrolls through that table. So you can see, and we can fill in from that table. So if you notice, that was our first point. -3, -3, -2, -1. Now we're just going to fill in our table. Here's our x, and here's our f of x, or our y. -1, 1, 0, 3, 1, 5, and then just continue. You're going to scroll down so you can fill in the entire table. Okay. I know that you guys know how to multiply an input by 2 and add 3, so we are going to go right to our calculator. So -1, comma 1. The next one should be 0, 3, 1, 5, 2, 7, and 3, 9. Okay. And then draw that graph on this set of axes. Okay. 1, 2, -3, 3, -2, -1. You can start to see what's the slope happening here, and you can see that. Okay, it's up 2 over 1. That should be my next point. 0, 3. Up 2 over 1. That should be my next point. 1, 5. Up 2 over 1. 2, 7. And then up 2 over 1. There's my last point. 3, 9. Please use some kind of a straight edge. Okay, big fan of the straight edge. I shouldn't put an arrow on that. And why shouldn't I put an arrow on that? Okay. Well, this table just goes from -3 to 3. So I'm just going to make this a line segment. Okay, a line segment. Okay? We could go on, we could extend that, but because that table is there, I think I'm just going to leave it as that, a line segment. All right? Let's go ahead and flip the page. So it says, never forget that all we need to do to translate between an equation and a graph is to plot points, okay, according to whatever rule. So let's look at a nonlinear function, okay? Back to a quadratic, a very simple one, okay? It's just our f of x equals x squared. So with this one, because that's all you're doing is you're squaring the x, it's probably going to be quicker for us to do this by hand than to actually go to the calculator and do that. So if I take -3 and I square it, I'm going to get 9. So my point's going to be -3, comma 9. So if I took -2 and square it, I'm going to get 4. So it's -2, comma 4. See the pattern that ends up happening? I'm pretty sure you guys know how to square things. Okay, if we square 0, we get 0 back again. Okay, 1, 1, 2, 4, and 3, 9. Hopefully you're seeing some patterns that are happening, especially with the outputs with a quadratic. If you kind of look down your outputs, hopefully you're seeing some kind of pattern there, which that's by no coincidence. That always happens. All right, so let's graph that. So -3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9. -2, 4. 0, 0. And then you're going to start to see, okay, some nice symmetry there, right, in that one. I'm going to extend this one and put arrows on it. Y equals x squared, or you certainly could label it f of x equals x squared. Okay? Next part. Okay, so I'm going Sometimes a function rule gets all sorts of funny and can include being piecewise defined. Okay, there's that word again that came up in our last lesson. These functions have different rules for different values of x. Different rules for different values of x. That's huge. Okay, these separate rules combine to make a larger and more complicated rule. So let's look at one of these. So let's consider this function. So f of x is defined as 2x plus 6 when x is less than 0. So that's the first piece of it. And the second piece that makes up the f of x function is 6 minus x when x is greater than or equal to 0. Okay? So it's still one function, f of x, but it's got two separate parts depending on the value of x. So let's evaluate. Okay, let's start with that. And we know how to evaluate. So f of 4. So when x equals 4, so we've got two rules that make up our bigger rule. Which one do we go to? If x is equal to 4, does 4 fall into 4 is less than 0? Or does 4 fall into 4 is greater than or equal to 0? Hopefully you're saying the x is greater than or equal to 0. So that's the piece of the function that we're going to substitute into. So 6 minus 4, and we get 2. So then f of negative 3, again, go back to your function and see which one is true when x equals negative 3. So is negative 3 less than 0? Is that true? Yes, it is. So that's the piece of the function that we're going to do our substituting into. So negative 6 plus 6, that's going to give me 0. So you can see how you can evaluate given a piecewise function. You just got to be careful as to what piece you need to substitute into given the particular input. Okay, so let's go ahead and let's enter this one into our calculator as well. Okay, so entering into for a piecewise function is going to look a little bit different. So let's go back to our calculator. Let's go home. We're going to not save, and we're going to pick a graph. But because my piecewise function has two parts, I've got to tell it that, right? So I'm going next to the 9 key, and right here is my piecewise function. Okay, so I've got to enter in the first part of it, 2x plus 6, and then I've got to enter in that inequality, that domain piece of it. X, now where do I get those inequality symbols from? I've got to go into control equal sign, and it's less than, and it's 0. So now I've got to enter in that second piece of it, which is 6 minus x. 6 minus x, and then its domain is x is greater than or equal to. So again, control equal sign, greater than or equal to 0, and I hit enter. Okay. Now I'm going to move that label. I'm going to grab it and slide it over. Okay. So this is my piecewise function that's given to me, and now I've got a table to fill in. So I'm going to do the same thing I did with that first linear function. I'm going to, if I want a table, I'm going to go to Control T, T for table. Okay. And it's going to define this for me. So back on my table, I got a refresh, and it starts at, it goes from -3 to 3. So I'm going to scroll through my table. So the first point, -3, comma 0, -2, 2, -1, 4, 0, 6. Okay, you guys know how to evaluate and know which piece to go into, so let's let the calculator do a little work for us. All right, so let's get those points down on our paper. Okay, so -3, 0, -2, 2, -1, 4, 0, 6, 1, 5, 2, 4, and 3, 3. Okay? I'm going to let you guys go ahead and graph those on the set of axes here. I'm not going to waste your time. We're almost at 15 minutes. Graph those, and obviously your graph should look exactly the way your calculator does.